Hello student, I am Arnab Das. Today we discuss about the burst error. A burst length L can be defined as a vector whose non-zero elements are confined to L successive positions in the vector. By through an example it will be easy for understanding, and for this reason we are going through an example. Let we consider a error vector E is this one. That is, E is given as 0010 110101 000. If you want to identify the burst length, that time at first you have to check that at the LSB side and the MSB side where the 1 is present. If you check, this is the LSB side, 1 is present, and at the last one MSB side is present in this position. So if you consider this total section, the number of bit is used. If you count that time, it will be 8. So for this error vector E, the burst length is 8 on there. Again, I just repeat that you have to identify for the error vector where the MSB side and the LSB side 1 is present. The length between this will be defined the burst length. In this case, this is 8, so burst length is 8 on there. Now another one example you just consider for this same phenomena. Let the error code is this one. The error code E is defined, or error vector is defined as a 001101 0000. So here LSB side is present in this position, and LSB side, MSB and LSB side position is put in this section. So number of bit is used on there, total 4. So L is 4 on there, and burst length in this error vector is 4. Linear code is said to be an L burst correcting code if and only if it is capable of correcting all error bursts of length L or less, but not all burst error of length L plus of 1. So when a linear code will be the L burst error correcting code? Only when that particular kind of code can correct burst of length L or less, that time it will be defined as a L burst correcting code. For the above definition, it is clear that the problem of burst error correcting codes is to design an n, k linear code that is capable of correcting burst of length L with the minimum amount of n minus of k parity bits. So this is the important thing also. Now we are considering for BCH code, which is required in here for the previous section, and for this reason we just initially talk about L, that is the burst length. Now we are considering the special kind of code, that is the BCH code. BCH code, also defined as a name by three mathematicians, Bose, Chaudhary and Hawkinson. And for this reason, this code is defined as BCH code, are a set of random error correcting code. And there's some specific specification is present, that one you should have to remember. For any positive integer, let the integer is m. If it is greater than equal to of 3, there exists a BCH code. So you should be remember that any positive integer where it can be considered as a m, if it is greater than equal to 3, there exists a BCH code with the following property. Block length n should be equal to the power of m minus of 1. Parity bit n minus of k should be less than equal to of m into of t. T is defined the error correcting bit number, and minimum distance d min should be greater than equal to of 2t plus of 1. The code obtained by above said parameter will lead us to the T error correcting BCH code. Due to the reason of that, T is the error correcting bit. So in this case, T number of error can be correct by this kind of BCH code. As BCH code form a subclass of cyclic code, BCH code also defined as a subclass of cyclic code. They can be characteristic by its generator polynomial. The generator polynomial Gx for a BCH code can be defined as the minimal monic polynomial over Galois field 2, which has alpha, alpha square, alpha cube up to alpha 2t as roots, where alpha is a primitive element in Galois field to the power of m. That is, g of alpha I should be equal to 0 and I in between 1 or 2t. That is, the I may be greater than equal to of 1, or it may be less than equal to of 2t. So for a Galois field has alpha, alpha square, alpha cube, alpha power of 2t, and their conjugates are root also. These are the root for there. Let phi of ix denotes the minimal polynomial of alpha to the power of I. Then the generator polynomial can be produced by LCM of phi of 1x, phi of 2x up to phi 2t of x. This is the main and important thing, because if you able to identify for any kind of code the generator polynomial, then you can able to identify what will be the code word or code polynomial also. So generator polynomial for this BCH code will be defined as such, that is the LCM of phi of 1x, phi of 2x up to phi 2t of x. If I is the even number, it can be expressed as I equal to I1 2 of L, where I of 1 is an odd number and L is an integer, and L should be greater than equal to 1. Then alpha to the power of I equal to alpha to the power of I into of 2 to the power of L. So this is given as such, fall under the conjugacy classes of alpha of I 1. Therefore, alpha of I and alpha of I1 fall under the same conjugacy class. So equation number 1, that is the g of x, the equation which is given on there, can be specified as gx is equal to phi of 1x, phi of 2x, phi of 2t minus of 1 up to x, as the degree of the minimal polynomial is m or less. The generator polynomial degree can be at most equal to MT. Therefore, the parity bit n minus k can be at most equal to 2t on there. So this was the BCH code. What is the way by which we have to generate the generator polynomial for identifying the code word by using the BCH code. BCH code was invented in 1959 by French mathematician Alexis Ohningen and independently in 1960 by Raj Bose and D.K. Roy Choudhury. And for this reason, this is specified as a code of BCH. For your simplicity and for your notation, there's some specification is given to you. Number one is that if you want to factorize this one, a to the power n minus of bt, it will be as such, you can be write down on there. This is required because you have to get the value for the LCM. So you have to identify individual term into the factorialized form. So what is the way by which you can factor? This kind of expression can be helpful for you. So for this reason it is given to you. And when n is the odd number, that time formation will be look like this one. And synthesis division is the process by which you can do this one. As an example, it is given that you want to divide 5x cube 8x squared plus of 9x plus 12 by x minus of 3. How can you do this one? You just identify the coefficient from that individual one. If there any term is missing, that particular term position coefficient, you should apply the 0. So in this case, this will be the 5 to the reason of this. This is the minus of 8. You should write down minus of 8. Then 9, 9, 12, 12. After that, you just divide by the minus 3 in this. So you just apply the 3 on there. So what will be the value? This is equal to the 0. So x is equal to coming as a value of 3. In this way, you have to put here as a value of 3 on there. So what will be then? You have to multiply between these two, that is 3 into 5. The result you just put in this position. So it will be 15. Then the result is coming on there as a 7 on the value. Then multiply these two, then what will be the value? This will be 21. Put this position. Now the result after addition, 21 plus of 9, it is 30. Then 30 is multiplied with the 3, so it will be 90. We again added this 2, so it will be 102. So the result will be as a form of the quotient will become, that is the result will become as the value of 5x square plus of 7x plus of 30, this one value, and remainder will be the last one, that is the 102. This will be the come as the value of remainder. So this is the note by which you can be do the process at the time of BCH code, their generator matrix identification. Next day we should come with the example of BCH code and what is the way you have to specify or identify the term which is given to you, an example of BCH code. So today we discuss about the theory or the way by which you have to form the BCH code, and hope you are little bit able to understand, though it will be clear after some example, and we should meet for the next class. That time it will be totally clear with specified example. So now I have to say thank you and have a good day.